Now, any theoretical physicist on the street these days will tell you that quantum processors are the next logical step in the evolution of mathematical computations. But for those of us just barely capable of tying our own shoes, many questions spring to mind. What does theoretical physics have to do with improving processor performance? Is this going to end up benefiting me in any way that is actually relevant? And most importantly, will this next leap finally be the one that takes me home? Oh boy! Unlike classical processors, which use transistors to create digits of binary code called bits, which are represented in the familiar form of zeros and ones, quantum processors use atomic-sized structures such as a single freaking electron and produce coded units called qubits, which have the unique capability of being both the values of 0 and 1 simultaneously. More on that later. To accomplish this, engineers utilize extreme cold conditions and magnetics to manipulate the natural polarity field within the electron and bring it to a position where it rests in alignment with the artificially created magnetic flow. This resting state is referred to as spin down and would be similar to a 0 value in classical coding. When the electron is forcefully going against its natural inclination to rest with the flow of the magnetic field, or its polar south has been spun to the top position, that is called spin up, which, you guessed it, represents a 1 in traditional binary speak. Let me use an analogy to clarify. Imagine you're a child back on the playground, sitting on the swings. If you were just sitting there, exerting no effort, letting gravity hold you in place, this could be considered the spin down position. Now let's say you were to accomplish the dream of every child around the world and manage to be all the way vertical up above the bar. Spin up would be the point at which you reached the apex of your swing and gravity was working its hardest to pull you violently back down to the earth. Now, as I mentioned earlier, qubits have the unique potential to end up representing both a 1 and a 0 in code value simultaneously, which you could imagine in our previous scenario would be like a swinger sitting at the 90-degree mark directly between the ground and the sky. But just like gravity would make it impossible to stay at that position for more than a fraction of a moment, the electrons which drive the quantum processor have forces preventing them from sitting still as well. In fact, that might be underselling it a little bit, because thanks to the quantum mechanical phenomenon known as superposition, the electron is actually moving in all directions simultaneously before the moment it is measured. So in order to quantify information derived from an electron spinning out like a roided out hamster in a ball, engineers first determine the basic spin value as previously described. Then they use mathematical probability scales which calculate the likeliness the electron was actually spinning in the indicated direction, and then arrive at two separate numbers for each scenario, which are the processor's outputs. For instance, one might receive something like a 70% probability up and 30% down, or as you now see, both 0 and 1 at once, if not at least to varying degrees. This form of measurement, coupled with the electron's unique physical properties, lead to a quantum processor's two main advantages over a classical one. So here's the summary part. First, since the electrons are spinning at such an indeterminable rate and direction, they are also potentially capable of running an indeterminable number of processes at remarkable speeds. Secondly, since two measurements are needed to quantify each qubit value as opposed to the standard 1 transistor per bit rule, the increase in computing power for quantum processors is an exponential one. In other words, when one qubit tells two friends, they tell two friends, and then they tell two friends, and I'm gonna run out of fingers on my hands really fast here, until you reach the measly range of 500 qubits where you've generated more possible processors than there are particles in the known universe. But now to the downside, or the spin downside, as it were. Oh, that was a bad joke. While quantum processors may have more computing power than the whole known universe plus He-Man, because of all the insane amounts of effort it takes to isolate, manipulate, and quantify something like an electron and its spin, these computers would likely only see a benefit when running intense, multi-tiered operations that take advantage of the system's ability to run calculations against each other, such as weather and traffic predictions. So for things that run... Speaking of the king of the roost, we have a sponsor for today's episode, and they're the king of the roost in my book, at least for the next 30 seconds. Cooler Master has actually some pretty cool stuff going on. So aside from their, high quality cases, power supplies, and you guessed it, cooling products, which you can find more details about on their website. They have a pretty freaking serious business modding competition going on right now that anyone is welcome to enter. So you guys should check out the link in the video description for more details about that. And if you're not a modder, then make sure that you also check back and just have a look at some of the crazy things people are going to submit. There's a number of different categories, including modding existing cases and even a scratch build category where people will be building their own cases. So it's nice to see stuff like community involvement from these larger companies, whether it's sponsoring something like this fast as possible or sponsoring modders to do what they do and making sure they win prizes just for doing it. Thank you guys for doing the thing where you watch this video. Like it if you liked it, dislike it if you thought it sucked, leave a comment if your feelings were more complicated than that, if you have suggestions for future fast as possible episodes just like this one or hopefully different because we already did this one. And as always, don't forget to subscribe.